Hey, my name is Mntwana. Let me get a cup of coffee before I get started. Because we get into the business. And hey, listen, man. It's very important you go to the Instagram and follow me, Mntwana_Wabantu. Why? It's very, very important because, let me tell you that. There you get to see the program we have, feeding the brothers and sisters. It's not only feeding them, it's a feeding homeless. You know what I'm saying? Homeless, not only homeless, even our own brother. We feed among each other. We help one another. Subscribe there. Follow me on the Instagram, Mntwana_Wabantu with a small letter. Mntwana_Bantu. On Twitter also is Mntwana_Wabantu. If you need my service, you can direct message me. Mntwana_Wabantu is my Instagram. You can DM me right there, direct message me, or you can email me. Mntwanawabantu@gmail.com. Mntwanawabantu@gmail.com. Like, hey, go and visit it. You see the problem we have. Is the program we have is not only help a brother sister, also equip them with the skills so they can be independent. So they can have a independence mindset. My apologies. Right? Let me just turn this off. My apologies. People start to call me. My apologies. Let me just turn off everything so I'm not gonna get constant call. All right, we're ready to go. My apologies. People trying to interfere right now. We're busy. Okay, now let's say the system vibrates according to the equation. So they give us equation, differential equation, x double prime, whatever we have. So now let's get started. So let's say x represents displacement and t time. The general solution for xt using the method of undetermined coefficients. How are we gonna do this? So all you need first, right? You need to get out. Okay, let me write for you general solution. How the general solution look like? Okay. So first and foremost, you need to know the general solution. General solution, xt. We're gonna get. You're gonna have to add general solution. You have to add auxiliary solution. Auxiliary solution represented by xc, and then also you need to get particular solution represented by xp. So if we can get xp, auxiliary solution, and particular solution, then for that case, then you should be able to get what we're looking for. So now let's find the auxiliary solution. So to get auxiliary solution, we're gonna say, let me write here on top. Let me see if it's my space on top. Oh yeah, okay. So my auxiliary solution, I'll take this one right here. So in differential equation, right? If it's second derivative, some people use the letter R, some people use the letter M. So it's optional. Okay, for me, let me use M. So for, oh my God, let me just switch off this one. My apologies, because people constantly call me, and I'm busy right now, and I apologize for that. Let me switch off completely. Okay, notice my apologies. Okay, so now we're gonna say we say either you can use letter R to get auxiliary solution, or you can use letter M. So for second derivative, like here, the second derivative is gonna be M squared. If it's first derivative, it's gonna be just say M. But if no derivative like this, then you just say that number which is here 9. So we're gonna say now for this case now, now we say, well, so second derivative we say is going to be m. Let's say this how to use m. So now let's find the auxiliary solution. Which is xc. So this is going to be what's going to be m squared. So how are we going to get auxiliary solution? I'm going to say, so auxiliary solution, I must say, okay, let me put colon here. M squared, but you can use r. Some people use r. So we don't have first derivative. If we had, let's say we had a 4, let's say I'm just saying 4x1 prime. And then this could be 4m. But now we don't have no first derivative. So no m. Now here, if you have just xt, do not write m whatever. Just write the number which is here. But a first derivative, we were supposed to write with the m. So now it's going to be just simply plus 9 equal to 0. Find the value of m. So we're going to say m squared equal to -9, and then you square it and you square it. Oh, I believe complex number. So it's going to be plus or minus 3i. So that's going to help us to get the auxiliary solution. What is the solution? So we're going to say the auxiliary solution we're looking for here. So equal to, we got m equal to 3. This number here, that's what you need. This number. Don't worry about the rest of the stuff. So you can say auxiliary solution equal to, but hey, first and foremost, you need to look at the right here. This tells you how the format of auxiliary solution. So it's kind of more of the trigger. You see what I'm saying? but it's going to have a what? Number 3 now, because this number we get 3. So it's going to be the trig form, the auxiliary solution. But you have to use this number here. For now, it's 3. So I'm going to say now, my auxiliary solution is you always say A, and then you say cos. You memorize this, right? Cos. And then you put this number right here. You see this number here? This number used, which is going to be 3. And then you put to the T. And then you plus B, and then sine, and this number here, T. So we already have auxiliary solution. So now we want to get the particular solution. How are we going to get the particular solution? So to get a particular solution, what you do, you use the same one which you have here, but you put T prior to it. Okay, you put T prior to it. So then you want to say, I think I can write here. Let me see if it's my space, because I want to be sure I write it in front. Because sometimes I writing out of the line. Okay. Okay, so let's write it in top. So we're gonna say now, let me see. So we're gonna say now, we're gonna go for particular solution. So to get particular solution, what you're looking for, so this auxiliary solution XC, particular solution X, XP. How are we gonna get that? So you say XP equal to, by starting with, let me see face. Okay, because the other time I was writing and then I was write out of the frame. Okay, so we're gonna say XP equal to, I'll use a red color. You're gonna use the same one, A, but the only thing you do, you put T on outside. So it's gonna be A cos of 3T, and then you plus B sine of 3T. So what you're gonna do, find the first derivative, find the second derivative. Why we do that? We do that because, look, you didn't want to have the second derivative. There's no first derivative, find it. And then you're going to come and place an original solution here. And then you compare the coefficient, because you want to have A and B. Look how I'm going to do this very easy. So let's find, this is going to be XP equal to, this is the particular solution. You see, it looked almost like that, but what you do, you put T outside here. Let me say something very, very important, right? Differential question, my beautiful family, is different. It depends on the look. Like, okay, if I look like this, I'm going to do this way. That's why even here they say use the method of undetermined coefficients. So now we're going to say XP face derivative. Let's face derivative XP face derivative equal. So we know this is a product rule. Put this on constant. When you differentiate this one's going to be, 3 is going to come to the back. It's going to be negative 3a, and then sine 3t, and then this is going to be plus 3b. Let me write it. Plus 3b cos 3t. We plus product rule. Now we're going to plus this t. Now we're going to put this constant, and then we differentiate. When you differentiate, t is going to be 1. Product rule, right? So it means you're going to have exactly how it is, because now we put this constant to differentiate t. When you differentiate t, you get 1. So it's going to be a cos t plus b sine 3t. Okay, sine 3t. And the next thing here, we have to find the second derivative as well. Find the second derivative. So it's going to be, second derivative is going to be long a little bit, right? So we're going to say x. Okay, x second derivative of a particular solution. Okay. So let's start with this group here, and then we're going to go for the next one. So if you differentiate this, let me put this bigger bracket. Okay, put this constant. Okay, that was dead a little bit. Sorry. So put this constant. Now let's differentiate all of this. Now, okay, when you differentiate this, it's going to be negative 9a. When you differentiate sine, it's going to be cos 3t. Now, for the next one, remember, right? Okay. Now remember this one here is going to be when you differentiate, it's going to be 9. But remember, this is going to bring it negative, so it's going to be negative 9, and then this is going to be sine 3t, yes. Now remember the product means you did. So we put this constant differentiate. Now this is going to be constant, then differentiate t. When you differentiate t, you get 1, so you write exactly. So this is going to be plus minus 3a sine 3. Okay, 3 uh 3t, 3t, and then now we plus 3b, 3b cos, space, okay, let me do this, plus, okay, 3b cos of 3t. Okay, now we continue, and then we must come and differentiate that one right there. So you differentiate that one, it's going to be 3, it's going to be negative 3 cos, sine, negative 3 sine, because we differentiate this one, all of it, because we don't have another one, negative 3 sine, 3t, and then we plus 3 cos 3t. So we have finish all of this. Here's the negative. Okay, the top one, okay, this was the top one. I mean, this one here, and this one here. So what we're gonna do, we can try to group them together. T with a T, whatever. Okay. So what we're gonna do, we have a second derivative, and you have a base derivative, and you just have an xp. Okay. So now let's group them together, and then we're gonna come in a place here and compare the like coefficients. Okay. We're gonna come and compare the like coefficients. So we're gonna say now, let me group them so well. That's on the top. So I'm gonna say, let me put the t together. Okay, so I'm gonna say, okay, x particular solution equal to, okay, particular solution equal to. Now we're good. Now, which one is gonna have a t? Look, this is gonna have a t, and this is gonna have a t. This is gonna be negative. Even if I don't substitute in, I don't have. Oh, whoa! I forgot. Here we have a. My apology, a. And here we have a b. Sorry. Okay, so if you can look careful, this is gonna have a t, but this is not gonna have no t. So I'll take this one and that one together, because this doesn't have a t, this doesn't have a t. So I'm gonna say now particular solution second derivative equal to. I'll write how it is here. You just have a t. Okay, so I'm gonna say negative 9. Space. I don't want to finish a lot of space. Okay, let's do like this. Particular solution equal to. Okay, this is gonna have a t for both of them. Whichever one. Use that one above there. Okay, I'll say t. Okay, negative 9a cos 3t. Okay, minus 9 sine 3t. Okay, now we come here. Negative 3a sine t. Negative 3a sine t. So it's going to be negative what? 6a sine t. Sine 3t, my apology. Okay. Negative 3b cos t. Negative 3b cos t. So it's going to give us positive 3, and positive 3 is going to be positive 3b cos 3t. So if you can look careful, right? Let's do like this. Or let's do like this here. Sorry, my apology. Say plus and here minus. So what I'm gonna do, if you can look careful, right? This stuff here, I'm gonna take it, and because the second derivative, and then I'll replace it with that. And the xt, we have it too. What is xt? See, so we have a particular solution. So we're going to take all these second derivative, we're going to substitute because this is second derivative. And the face derivative, we don't have face derivative, but I have an xt, which is this one here. I'll substitute in this equation, compare with that, and see, and get the value of a and b. So now let's substitute very slowly so you can see how I get the answers, okay? Because I want to show you how I get the answer. Okay, now let's substitute x second derivative of a particular solution. So that's what we substitute in here, because this is a particular solution here, okay? That stuff is going to come here, okay? Second derivative, this one here. So then it's going to become all of this exactly plus, okay? So we're going to say negative 9 a cos 3t plus minus 9 sine 9 9 must be b here, my power b. It must be b here. 9b. I'm sorry. 9b, and then we say sine 9b sine 3t, because substitute the second derivative in here. Okay, and then we say plus. But hey, both of these have got t. I forgot to put t here. I'm gonna put t here, and this must have a t. Okay, t. Now we plus with plus, -6. Let me use the red pen here. -6a sine 3t plus 6b cos 3t. So what we do now? Plus, because it's not that one. Plus 9. Let's put here. Bracket. What is the xt? Our xt we know. What is xt? Our xt equal to that one right here, which is t whatever. Okay. So we're gonna say now, our xt. Let me see careful. What is my xt? Okay. Okay, yeah, I got it. What is our xt? Our xt is this one here. Like xt on the particular solution, both for particular solution that you substitute here, both for particular solution, which is going to be t. Sometime, okay. Okay, t bracket, let me bracket. T bracket a cos 3t, and then with plus b sine 3t. And then what we do, this is gonna be equal to 6 sine 3t. So now we're gonna compare the like coefficients. Okay, so if you can look careful, right? This has a t. Oh no, it's not all of them. This has a t. Let me see. Does it have? Okay, let's see. Yeah, both of these is gonna have a t. Look, all these have a t because we're gonna multiply t. All of them is gonna have a t. But you most of the time look at the right hand side. See this right hand side? It does not have a t before because I want to compare. So if you multiply in all of these, going to have a t, all of them. So I don't think I'm going to compare with that. Even this one is going to have a t, everything. If you multiply, it's going to have a t with something, t with b sine, t with, it's going to be 9a cos, 9t, 9bt cos. Or it's going to have a t. But on the right hand side, there's no t before. You see this t before? So even this on the left hand side is going to have a t before. But if I compare with the right hand side, there's no t before. So it means I'm not going to use this. I'm not going to use this for compare the coefficients. However, this one does not have a t before. Even this does not have a t before. So I'm going to compare this one and that one to get the value of a and b. So I'm going to say -6a sine 3t, and then plus 6b cos 3t. And then equal, because those one cancel, right? Because I say there's no t here. Equal to 6 sine 3t. So let's compare the like term here. Like terms, look. We have a sine and sine we can compare. There's a cos, there's nothing, means I can say 0 with something. So this is going to compare to the 0. And this is going to compare with that. So for that being said, I'm going to say, well, -6a sine 3t equal 6 sine 3t. So I can simply divide by -6 sine t, -6 sine t, -6 sine 3t, -6 sine 3t. So this and this cancel. So a, because this got left with a on the left, equal to, cancel everything is equal to -1. A equal to -1. A equal to -1. And b equal to 0. Because when you compare this with the 0, when you divide by 6 cos of 3t, by 6 cos 3t is going to be equal to 0, because you want to get the value of b. So b equal to 0. Choose my code. So we got a and b already. So since you got a and b already, maybe you can substitute in a particular solution to get a particular solution. An auxiliary solution. Because intention want to get particular solution and auxiliary solution from beginning, like I mentioned, because for us to get general solution, we need to have a particular solution and auxiliary solution for us to get the general solution. So we know a and b. So I can get a particular solution here, say a particular solution equal to t is t. What is my value of a? A equal to -1. So it will be -1 cos 3t. B equal to 0. So I'm not going to add that anything because it's going to be equal to 0. So this equal to a particular solution equal to -t cos t. Okay, now what is auxiliary solution? Auxiliary solution equal to, or we said before, our auxiliary solution when we use that, look, when you solve for x equal to m equal to plus or minus 3, and then we say auxiliary solution, it was like a, and then we say cos 3t plus b sin of 3t. That's what auxiliary solution. Do you understand that? So now a, we know what the value of a equal to -1. So we say our auxiliary solution equal to negative cos 3t. What is a b? Oh, wait. My apologies. Sorry, my apologies. We don't substitute this in auxiliary solution because those value is not for auxiliary solution. Those value was for particular solution. I'm sorry, right? So for that being said, now we can put them together. We're gonna say now general solution equal to particular solution plus auxiliary solution. What is a particular solution? A particular solution now we know equal to that one. Negative t cos 3t, here must be 3t, and then we plus, and our auxiliary solution we know is this one here, which is a. So we're gonna plus by a. Let me use a black color. A cos 3t, a cos 3t plus b 3t. So we can simply plug this together and say, well, solution needed, which is general solution equal to, this is cost and this cost, so I can just say cost out, cos 3t out, this is going to be a minus 3t, a minus t, a minus t. Sometimes I say 3, but I mean t. It's just a tongue error, okay? You understand what I'm saying? If I fuck it, look, because look, this and this is the same thing. So I'm going to say now cos 3t out, and here I'm going to say a minus t, okay, and then plus b sin 3t. So this is going to be our final answer for that case, okay? So final answer I can write again here at the bottom, for you to see, is gonna be x, okay, a equal to a minus t cos 3t plus b. Oh, for that being said, man, subscribe, leave a comments if you want to make to solve all this video here. Give me feedback, and then I'll show you all this video. Like, hey, if this video was helpful, or you want me to continue to make these type of videos, share this with a lot of people, man. And that's gonna be a final solution. For that being said, my name is Untitled Wabantu. You know, and hey, we can stop here, man. Let me have some coffee. Easy, man. Easy.